welcome to this video. In this video, we're going to talk about Micro850 PLC. This is the course in which you will learn how to program Micro850 PLC. And this is very interesting because if you don't have a PLC, the software supports PLC Simulation. So you don't have to worry about not having a PLC. You can still practice the course using the simulation inside. So in this course, we'll see some programming instructions and interfacing with different technologies using Modbus, and I'm also going to interface Factory I/O to make it more interesting. And later on, we will also interface this PLC with the cloud. And how are we going to do that? We're going to see later in the courses. So let's see, what do we have in this video for today, which says Micro850 PLC. This is an introduction video. We'll talk about the PLCs. And the PLC which I'm using is this one. So if you see here on my screen, I have this Allen Bradley PLC Micro850, and this is connected to some inputs. You can see on the left side, these are the inputs, and the outputs are connected to some of the lamps, which I will show you later, but you can see the status of outputs here. And this is the status of inputs. So I have this strainer already connected. I'm going to talk about the wiring of the strainer later in the video, but if you see here, I can actuate my inputs using these buttons, and you can see the status of the outputs on the PLC because there is a sample program inside. We'll come to that later in the video, what is happening inside a PLC. So let's see what is the content of this video. Starting with Micro850 features. Now there are a lot of text on the screen, but I will come to that one by one. What are the features and what are the different terminals which are connected to this PLC? So let's start with the top. It says input indicators. So here you can see, I already shown you in the video, we can see the status of your input on this input indicators here. So this will tell you which input is true or false based on the lights. So at the moment you can see my input 0, 1, 2, 3, and 4. These are true. And if you count, there are total up to 14 inputs in this PLC. Alright, so this was just the status of inputs. And then you will see status indicators. So this part of the PLC will tell you the status of the PLC itself. So if you see on the top, it says MS, which is a module status. Module status means the different module which are connected to the PLC. And then you have NS network status, which will tell you the status of the network. For example, Ethernet port, if it's connected, if it's working, what is the different meaning of that? Then you have a power status, if PLC is powered on or not, and the run status, fault, force, communication. So we'll see the status of this PLC while programming the PLC, and then I can explain you much better about the status. But very quickly, you can see the status on the PLC. So at the moment, if you see, MS is module status, which means there is no problem in the module. NS is network status, and you see there is no Ethernet cable connected, so network status is off. And PLC is powered on, and it's at run state without any fault, without any force, and without any communication indication. So fault, you will understand the fault is if the PLC has a fault, it will show you a red light here. And the force mean if you forcefully turn on the input, not from these physical input, but from the software itself, then it will show you the force indicator. Communication will tell you if the PLC is communicating via these RS-232 communication port. So this was about status indicators, and coming back, we can see here we have RS-232, RS-485 serial port. So you can also communicate this PLC with other devices which supports this communication. You have Type B USB port you can also use it for programming. I've never tried that. I'm programming the PLC using Ethernet port, but you also have a USB port in this case. Then you have a mode switch. Now this is very interesting. You have three status: run and REM and program. This is run, remote, and program. I will talk about that in the next slides. So you have a mode switch, which I find really interesting. Then you have output indicators here. This is similar to what you have seen here. So these are the output indicators, and at the moment you will see output 0, 1, 2, 3, 4 are true. Okay. And then you have 24V DC power input. 24 volts DC power, it needs a DC supply. So you need to have a power supply which supplies you 24 volt DC output, which you have to give here on these terminals. So we will talk about that again when we talk about the wiring of this PLC. And then you have output terminals on the bottom. So this is similar to what you have seen here. These are all the output terminals, and on the top you have all the input terminals. So you have connected input on the top and output on the bottom, and power supply over here. Very easy. That's coming back here. And then you have plug-in and extension I/O module. Now on this PLC, you will see in this Micro 850, I have just digital inputs and digital outputs. If I want to connect extra input and outputs, for example, if you want to connect analog inputs, analog outputs, or some more digital input and outputs, or temperature module, then you can connect extra module on this PLC. So there are some plug-in modules which you can just plug and play on the top of it. And then there are some expansion I/O modules which you can connect on the right side of it. So if you see the PLC again, so here we have plug-in module which I can connect here. So I have two plug-in module on my table. I will show you now. I have one of this plug-in module which is 20800F2, which is an analog output module. So this module I will connect to this PLC once we do analog output lessons. So for that I can just take out one of this cover here and plug in this module. We will see that later. And then I have another module which is 2080IF2. This module is analog input module, so I can read analog inputs here. And just to show you how this will work, I can just take out this one. So you can see there, I can easily take out this one, and then I just need to plug this module. If you see here, this is the 40-pin terminal. I can just quickly plug it inside, and then I have to screw it the terminal. So and then you will have analog output on your first plug-in module. But I will keep it out at the moment because we're gonna just talk about digital PLC lessons in the beginning. So let me just plug it back. Now this is intact. So this was about expansion I/O modules which you can connect to your PLCs. So you have various possibilities. If you don't want analog, you don't have to do it. If you want, you can just plug in or put an expansion I/O module on the right side. So different communication protocols which it supports Ethernet IP, very common in LM-Readly, it supports Ethernet IP. CIP serial, DF1, very common protocol for programming the PLC. And CIP symbolic, this is an Ethernet based communication. And several other communication like Modbus, TCP, RTU, which is very important. We're going to talk about Modbus when we talk about Node-RED, because I would like to make some dashboard of this PLC, and we will see how we can do that. And then you have DHCP clients, socket clients for communication to printers, barcodes, and PCs. So a lot of things on this PLC, and I'm quite interested to start PLC training lessons. But let's see what do we have in this training in this video so far. Next slide is about status indicators again. So here are some more detail about the status. For example, input status. If it's on, then it will be green. If it's off, it means input is not energized. And you can see clearly here. So I'm going to de-energize my input 0. In this case, you can see that the 0 LED is off. And here my input is off. So this is the input status, just on and off, right? Similarly, we have output status, which is on the bottom. In this case, 0 is off. And because of my program, here it means 0 is on or true, right? And then you have power status, which is always either green, or if there is no power, there is no color. It's just green and it's off. Then you have a run LED status here. Now run LED is off if it's not executing any program. And if it's green, it means it's executing the program. But if it's flashing green, it means it's doing some backup or memory backup in progress. So let's have a look. What I'm going to do now is I'm going to open the software which comes along with this PLC. This is CCW. And this software is free to download, and you can just install the software and start working on it. So we'll come to the software part later, but let me just open the software and you can have a look. What happens if I put the PLC into program mode? You will see the LED status will change. Okay. Let me just open the software and open the program which is inside the PLC. We'll just go to open and I'll go with my desktop. Here, LM-Readly course, program, test circuit. So I will just open the test circuit, which was already inside. And let's go online and check. This is just to show you the indication of this PLC on the PLC trainer. So I will go online. Okay, in this case, now you will notice I want to go online in this PLC. And here I have no Ethernet cable connected here. So first thing, I have to connect my Ethernet cable to go to online. So let me just quickly connect my Ethernet cable. Now you can see Ethernet cable is connected, and you will also see this NS network status is blinking, which means the Ethernet cable connection is trying to connect. And now here you will see this is my RS Links software, and this software comes along with connected component workbench. So once you install the software, this will be installed as well, the light version. And if I open this one now, Micro850, I will see two controllers. One is the controller, which is my real controller, this one. Wait a second. Here. So here you can see I have RS links already connected, and here you can see that's my controller. So this will come automatically, Micro850 EIP Ethernet. The software will search for this PLC by itself. And this is the PLC IP address, which is set inside the PLC. And I can select this one, click on OK. And don't worry about this part of the video. This is going to be repeating in the next lecture when we talk about programming. This is just to show you the status of the PLC. So now I am connected, and if I go to my PLC here, you can see here it's at run mode. Now if this is at run mode, you will see I have run LED, which is true here. Now I go back to my software and I will make it to program mode. And now when I go to program mode, you will notice the run LED is gone, because it's not in run mode anymore. This is what I want to show you, how this LED status you can check on the PLC, and you can immediately see if the PLC is in run mode or the program mode. Now I will bring it back to the run mode from the software itself. Wait, I want to show you. So in the software, I can just go to run. It will go ask for the confirmation, click OK. And now it's PLC back to the run mode. So you can see that here. This is one way to trigger the PLC to run and program mode. I will show you the next way in the next slides. So this was about the status of run and the status of fault. So I cannot generate a fault here, but if you have a fault status, then the PLC will have a red LED. Red. If the red is flashing, it means you can reset the fault. If it stays red forever, then there is a big problem. Okay, you have to consult the people who sold you the PLC. And then you have force status here. The force status means if you forcefully turn on the inputs or not. I want to show you that. This is also very interesting. So let's come back here. And now I will open my software again. Now in this software, you can forcefully turn on the inputs. One is by giving the voltage, that's not forcefully, but to do it forcefully, let's go to the program global variables. And this is my global variable, which shows the status of my inputs. Now you can see that I have my inputs 1, 2, 3, 4, 5. First 5 inputs are true. And these are true because of my switches. So if you see my switches, this is 0, 1, 2, 3, 4. 5 inputs are true, and this you can also change from here. So I turned off my fourth input. And now if you see my screen here, my fourth input is false. Now if I want to actuate this input forcefully without physical voltage, how can I do that? I can do that from here. So if I go to log, and now if I turn this on, wait a second, you first turn this logical value, and oh wait, this one has a physical contact. Here, physical value. And now you will see, once I do that, if I go to my PLC, you will see the force is true. And your input status will not show here true. This is the only status you will get when the voltage is applied on the external. And voltage is not applied because the switch is at off state. But your input 4 is true, because if you see here, this is true. Because I forced it. And because I forced it, you will see on the PLC this force LED is true. So this is one way to check if your PLC has forced input or not, and this is used in case of maintenance. When you're maintaining the PLC and your sensor is damaged and you want to actuate it internally to find out what will happen if your sensor, for example, if you are bypassing some sensor and your sensor is not working, but it's required to maintain for some maintenance activities, you can force the inputs, but it's generally not done for regular applications. So I will turn off this one, and once I remove the log, you will see here it will go back to normal mode without any force here. Very nice. Let's come back here. So these were several status. We have force, and then you have communication, which will tell you if PLC is communicating via RS-232 or not. You can read these slides in detail to understand more about the different meaning of blinking red, green, and this will be quite helpful when you have problems in your PLC. So this is about status indicators. Now let's go ahead and watch what is in the next slide. Next we have is the PLC wiring. So the trainer has been wired in a way shown here. So here you can see that we have given 24 volts to this terminal, 0 volt to this terminal, and this is coming via a power supply. Okay. And now, very important, how do you wire the inputs and how do you wire the outputs? It's very interesting. I can also show you this diagram in the software which I used to create it. This is called Draw.io. It's a free software you can use to create your diagrams. Here I can explain you much better. So here I have this diagram and I have some layers. So let me just select PLC. So in this case, that's just my PLC. 24 volt, positive is connected to first terminal, 0 volt is connected to second terminal, and this is something you can also see here. Here you maybe cannot see closely, but 24 is connected here and 0 volt is connected here. And this is used to power up the PLC. Once your PLC is powered up, you are able to program it. Okay, so coming back here, and to connect the inputs, I will activate the inputs, and now you will notice to the common terminal I have connected to a 0 volt. This blue wire is my 0 volt. So common is getting 0 volt, and all the inputs are connected to individual switches, and these are shorted from one end and has been supplied 24 volts. So when you actuate the input, it completes the circuit. Common gets 0 and input gets 24, and then your input is true in the PLC. Simple as that. You just need to maintain a potential difference of 24 volts. And this is done for all the inputs. And that's how your inputs are energized. And these inputs are connected in the trainers over here. So these are wired. So these are the wires going to the back of the trainer and coming back from the top like this. That's how your inputs are connected. And if you want to see the outputs, let's check it out, the outputs. Now in the outputs, I will just remove inputs to make it look focused. So in the outputs, you can see in the common, I have connected 24 volts coming from here, common 0, and then this is loop to common 1, and then loop to common 2. And if you see the outputs, these are coming from here. This is one output, this is second output, and these are 4 extra outputs. So what happens in the PLC, when you actuate the output inside the PLC, the common travels to the output. So common has 24 volts. When the output is true, output gives out 24 volts, and this is connected to my lamps. So maybe if you don't see perfectly in my camera, I have some lamps connected, and which is just giving some lights like red, yellow, green. So these are the lamps which are just showing a beautiful light on my trainer. All right. So, but this will come later when we do programming exercise. So you have connected the lamps to your PLC, and in the common, I have connected 24 volts. So this is how you have to wire. Just focus on 24 volt and 0 volt. Very simple. If you have any doubts in the wiring, if you have a sophisticated wiring, just let me know. I can help you in that. Or if you're trying to connect some sensors, I can also help you if you have any doubts or questions. Okay. Otherwise, just understand one principle, potential difference. You need to have potential difference in your inputs. And you also need to see what is coming out of your output so that you can connect your actuators. Okay. Very nice. Wiring, PLC wiring. I hope you don't have any doubts. Let's move ahead. And then we have different types of programming languages which the software supports. The software which you are using is CCW, Connected Components Workbench, and it supports ladder logic or ladder diagram. It supports functional block diagram, and it supports structure text. So in this course, we're going to talk about all these languages because in my opinion, all these languages are important. Structure text is important when you're doing some advanced programming. And from ladder diagram and functional block diagram, you can choose any of these two because both will do the same purpose. You can use ladder diagram where you can use functional block, but when you're talking about structure text, it's a bit complicated to use ladder or FED. So you need to learn structure text to make complicated loops, and it's very easy to move values from input to outputs. We will see that in one of the lesson where I'm talking about programming a robot in this PLC. And this software you can download for free. Just open this website, rok.auto/ccw, and you will navigate to a web page where you will find how to download this software. Very easy. So let's see what is in the next slide. And then we have download and upload the software. How to download the software and how to upload the software. There are two ways. If you're programming in your computer and you want to download to your PLC, we call it download. And when we say upload, it means you want to take out the software from the PLC to a computer. So we'll see that in detail when we talk about programming the PLC, how you can download it and how you can upload it. But there are three things I want to mention here. One is run status, remote mode, and program mode. It means when the PLC is in run mode, you can't change the program, right? This is a kind of security, and you will see that these three modes here on the bottom. If you see here, there is a switch, and here on the left it says run, in the center is remote, on the right side is program. So if I move this switch to the extreme right, now this is at run mode. In this mode, I cannot download the program. So this is a kind of interlock in your PLC. Very interesting. And if I move this switch to program mode, this only allows you to program the PLC. You can't run the PLC. So when you are just doing the programming for hours and hours, put it in the program mode, and then you can check it later what is happening. So if you see this PLC again, right now it's on run mode. If I move it to extreme right, you can see PLC run mode is gone because now it's just in the program mode. It's not scanning the input or triggering the output. It's just in the program mode. So I can just program the PLC. Interesting mode is in the middle. If I put this in the middle, it says remote mode. Now in remote mode, you can decide if you want to put it into the run mode or program mode using the software itself. So now, because it's in remote mode, let me open my software and I will go to my Micro850, and here I have position, what to do. I can bring it to run mode and it will ask you for confirmation. And then when I click OK, it will come to the run mode. And now if I go back to my software, do the program, another confirmation, now it's in program mode. I can't do that when it's only in the run mode. So let's try. Now I will bring this PLC to run mode from here. So now this is in the run mode. And what I do is I try to download the program. And you can see there, this option is faded. And now if I want to download the program, which I can do by going offline, and I right click, and here maybe you find download. Now when I try to download, it will ask me that the switch is on the run mode. So this is a kind of interlock you can provide to your PLC. Here you can see that. The mode switch is in the run mode. To continue downloading, move the switch to program or remote and click retry. So in this case, I have to maybe put to remote or program. So I will put in the center, which I find much better. Now it's in the remote mode. And now I will go here and click retry. So it will ask to retry and download. And now I'm downloading the logic. It will take a couple of seconds before it's fully downloaded. And once it's downloaded, it says download is complete. Do you want to put it back to remote run? I'll say yes. And now PLC is again in run mode. Okay. So this was about these different types of switches. All right, let's coming back to the presentation. So PLC simulation in CCW, yes, like I told you, you can also simulate your PLC. This is possible. So you don't need to have a real PLC. You can just simulate your PLC. Very interesting. So for example, here, right now, you know that I'm working with a real PLC, right? Now what I'm going to do is I will just take off this cable so that you know that I'm trying to simulate it. Now there is no way I can talk to this PLC because there is no communication port here. And you can see that this NS port is empty. or it's off. Okay, let's come back here now to our presentation. Now I want to still simulate the logic using my simulation. What I can do is, it says the connection is lost. That's good. You can see the button here, Start Micro 800 Simulator. Okay, so you can click Start on this icon here, and then you will see Micro 800 Simulator. And here you will see the IP address. Normally that should be the IP address of your Ethernet card. So you have to check what is your Ethernet card. So I'm going to select this one. This is my Ethernet card in my computer. So this is the IP address also of my computer. So here, once you know your IP address, you can power on your simulator. Okay, this will take a couple of seconds and you can see now the power LED is on, but it's still trying to connect. So what we can do is now, I can minimize this one. I go to my Micro 850 and here I know this is the PLC address of my real PLC, not the simulation. So, but I need to connect to the simulation PLC. What I can do is, here you have to first make sure which controller you have selected. So Micro 850, go to change controller, and here you will see on the right side, you have to have a simulation controller. So once you have this one, click OK, and then it will refresh the whole project and it will start the project again. So now if you see this part of the PLC, it looks quite similar to your simulator. So you need to have this controller here, right? Then you will click on this icon here. And then if you remember the IP address of your computer, which was this one, because this is linked to my simulation PLC, select this one and maybe double click on this one and you have this part and click close. And now you have this part and then you can connect. And once you connect, it will try to connect to your simulation PLC. So it says controller change succeeded and must take a couple of seconds. So we wait. It says the current project does not match, so we will download this project in our simulation PLC and everything seems fine. Download. So now looks like it's downloaded. It's still downloading. You can see the status on the bottom. Downloading project. Downloading resources. So a couple of files. Now it says succeeded. So you can open your simulator now. And just to show you how it works, I'm going to, so it's asking for run. For sure, I want to run. And now, very important, because you're using a simulation mode, it will only work for 10 minutes and then you have to restart it because it will move it to program mode, you can see here. So it's a kind of limitation when you're using a simulation mode, but I think this is not gonna stop you from learning. You can also reset after 10 minutes. So click OK. Now I will go to my program here. And that's my program. And you can see that this is running. And this is my simulation. It's a very simple program. One input is triggering one output. So input 0, trigger output 0, input 1, trigger output 1. Very simple. And now here to trigger the input, what you can do is just click here. This is my input. It triggers my output. Super easy. And you can see that here the state is also true. This is also true. Similarly, I can do for other inputs. And here, once you are simulating this value, you will see in my real PLC, nothing is happening. These inputs are just because of this here. So this real PLC is still using its real PLC program because the program is downloaded in this one, but you will not see the same status on the software because on the software now, you just have the software PLC. Okay. So this is very interesting. You can still program your PLC logics and practice my next lessons in which I'm going to talk about various PLC instructions and how you can use it. Super interesting. So this is the very good feature I like about this software, simulation. And if you want to turn off the simulator, just click it here. Or you can just close it. Okay. So this was a simulation. And thank you for this. Thank you for your attention. Thank you for watching this video. If you like this video, you can join the course if you're not in the course yet. And I hope I'll see you very soon in the course with the next lessons on PLC instructions. So see you in the video. Have fun. Ciao.